Hi everyone, welcome to another episode. So today the question we are going to solve is flatten a multi-level doubly linked list. So let's look at the question and then we'll discuss the approach and then we'll go into the coding part. So you're given a doubly linked list. In addition to next and previous pointers, so obviously doubly linked list is like it has a next, it points to a next node and it points to a previous node. On top of that, they have provided a child pointer, which may or may not point to a separate doubly linked list. Now these child lists may have one or more children of their own, and so on, to produce a multi-level data structure. Okay, flatten the list so that all nodes appear in a single level doubly linked list. You're given the head of the first level of the list. Okay, so let's look at this question first to understand it. So you're given a head like this. Let me quickly look at the code to understand if they actually give so my doubt is that if they actually give the array of these numbers or they have nodes in it. So okay, so they give the head of the node. Okay, cool. So what is the diagram depicts is we have one node 1, okay, node 2, and then it points to node 3, and then it points to node 4 and 5 and 6. Okay, now these null is there are three nulls. Okay, and then there is 7, 8, 9, 10. So basically they are trying to depict that when we reach 6, the last three nodes don't have any child node, and there is a child node from 3. So 3 points to a child node 7, and then 7 has its own list, and then 8 has its own child. Okay, now what does it want us to print? The output seems like, let's say, okay, initially I'm at 1, so I'll print 1, and then I print 2, I print 3. Okay, then it jumps to the child first, so I print 7, I print 8, and then it jumps to child again, I print 11 and 12. Now this here is where the list ends, so I return back, I print 9, I print 10. Awesome, and then I return back and I print 4, 5, 6. Okay, so here is an approach that is clicking my mind, that is in O of n time, which will take just one traversal, which is, it seems like there is a case where, okay, I can run a recursion. Okay, so I can start a recursion from 1 to 3, and if at any point I find that child node is not null, I get into the DFS for the child node and I automatically keep going deep. So DFS is depth first search, right? I keep going deep, and once I reach a dead end like this, obviously it returns back, and after the child node traversal is done, I would like to traverse the next pointer. I think the diagram actually pretty is pretty clear. We can directly jump on the code. Let's look at some few other examples to understand that approach is right. So we are given 1, 2, and then 3. So 3 is the child of 1. Okay, so we print 1 and then we 2, and then it returns back and we print sorry, we print 1, we print 3, and then we return back and we print 2. Okay, seems good. Okay, so this is the explanation. I guess we pretty much is explanatory from the diagram they have provided. Okay, so here is what I think should work. So we can hmm, we can I want to return a new doubly linked list, right? So Latin is you're given the head of the first level. Okay, so we need to return the head of the new doubly linked list. How about I go ahead and um, I create a global method variable for node, uh, sorry, it's Java, yeah, flatten head, and then I have public void dfs of node head, and then if let's say node is null here in this case, this is a corner case, equals null, return null, correct, and then and then I do a DFS here. In DFS, if I check if head equals null, which is it reaches the dead end, return, right? If head dot child, we like to traverse child first, not equal to null. So I can do this because it's a value. I can store all values in the array list. So let me do this. List integer integer array is equal to new array list. Okay, and then if head is not equal to child, I keep storing the values of the head in the list. So array dot I think array list add. I'm not good with Java. Okay, so it's add head dot value, and then if it's not there, we just do a traversal of child node first. So we go head dot child, or anyways it will return null. So if we just do DFS of head of child and then DFS of head of next, they should get me the array list which I need. So let me first print for integer I in arr, let me print this numbers to see that my traversal actually worked. Okay, and then I call here DFS of head. Let's see. So if all the numbers are in a flatten order, then creating nodes should be easy, right? It should be 1 2 3 7 8 11 12 9 10 4 5 6. Awesome. So that means everything is cool here. Now what we can do, we can create a node flatten head, right? And then we can just return. Let me do this. I need to check something else. Okay, so now flatten head should be equal to new node, and then I take and the index is equal to 0. So I just store the first element of the array. New node this flatten head, does it actually create that head? Let me check head dot value. So okay, 0. Okay, array list get 0. Yes, just check. Okay, it's 1 1. Okay, awesome. So this is working. Index is 0. We can pass an index here. Okay, so we get the first node created. Now what we can do is for integer we can write a for okay, we can do a while loop. So while index is less than size, I guess array list size method. Okay, size is there. Okay, now we create a node temp equal to new, and we do index plus here, and we do a new node, and we do array dot get of index, so it will point to the next element. And what we do with that is we do flatten head dot next will be temp dot previous, it is prev. Okay, prev is flatten head, and then flatten head is equal to flatten head dot next, right? Yeah, this seems good. And then next time when it moves on, so um, flatten head points to the temp node. Okay, so it should be flatten head becomes temp basically, yeah. Or next should work, yeah, but it becomes temp. Now temp is at 1, so I add a new list. I return this, so I can do this now while flatten head, just to check is not. Oh wait, I just need to keep a reference to the first node, right? So um, in order to move the pointer to next, I can do this. Maybe I can create a node is equal to flatten head and then node temp1. Okay, this way they will keep doing their thing, and then while is not equal to null, I will keep printing here. Flatten height not well, and then I change flatten is equal to flatten head dot next, right? So this should print all the numbers in correct orders if everything goes right. Time limit exceeded. Okay. Oh, my bad. We need to increment the index as well. So it's 1 2 3 7 8 11 12 9 10 4 5 6. Awesome. So we just return flatten head here, and we just remove this code. I was just wanted to test this. Let's run this and see. Okay, seems to work. 1 2 3 7 8. Let's submit this. Awesome, it got accepted. So I guess the approach was pretty simple, because it's more like, if when you're flattening, if I find a child node, just start the traversal in that direction, and automatically at the dead end it will return, and after the TFS of child node is complete, it will return here, and the traversal for next will start, and again the dead end will reach here, so it will return, and then it will start traversal here. So that way we will, so what I'm doing is I'm getting the values of all the nodes in the traversal, no matter what, whether they're duplicate or not. I just do a traversal in what particular order the flatten list should come. Once I have the values in this list, I just create a new doubly linked list and return the head of it. Hope this solution was pretty understandable and easy to approach. If you guys like my video, please subscribe to my channel and give me a thumbs up. Thanks everyone.